progress.
Okay, so this video covers the lesson for Friday, at least for this year. It's going to be Friday the 13th of January for Algebra 2. So we're going to start section 3.3. We won't get all the way done. We'll finish that next Tuesday when we come back. But I'm starting off with a bell ringer, which those of you that are having to watch a video hopefully have by the time you watch this video, so you can give it a try and see how you do. If you haven't, pause it, see what you come up with, and then see what you get here. So for the first one, what is the rate? This is an old school, again, just a bell ringer, just a review of what we previously learned. We're asking what is the rate of travel if a car travels 200 miles in 3 hours and 15 minutes. So this uses the distance formula, which distance equals rate times time. We know our distance. We're being asked to find our rate. So what we're going to have to do here is change this literal equation to solve for the variable we want, which is rate. So when we solve for rate, we need to divide both sides by time, which makes sense because we refer to the rate of speed as the distance traveled, or miles, over the time it takes to travel that, which is time, so miles per hour. So rate equals distance times time. The distance we're given is 200 miles, and the time we're given is 3 hours and 15 minutes, which I'm going to write as a quarter of an hour. So I'm going to convert this into division since I'm having to divide fractions. So this is 200 divided by 3 1/4, which 4 times 3 is 12, plus 1 is 13. So that's 13/4. And when I divide fractions, of course, we turn that into multiplication. We multiply times the reciprocal. And so we end up, probably could reduce that. Let's see. Does 13 go into 200? I feel like I get an even answer, so it should. Let me calculator 200 times 4. It's not, but I have 800 divided by 13, and 13 goes into 800, approximately 61.538 miles per hour. So I'm just going to simplify that to 61.5 miles per hour. So they were going approximately 61.5 miles per hour if they went 200 miles in 3 hours and 15 minutes. All right. So the second question that we had is, what is the simple interest earned if $5,000 is placed into an account earning 3% interest for 1 year? So this is using our interest formula, which interest equals the principal times the rate of interest earned times the time. Now, in this case, time is 1 year, and anything times 1 is itself. So I'm actually going to just not even bother with that variable. So the simple interest we're wanting to learn is the principal, which is the $5,000, times the rate, which I'm going to change that 3% rate into decimal form, which is 0.03. And solve for it. Now, when we multiply times a multiple of 10, I know that I can move my decimal place 2 places in the, excuse me, in the 0.03, which means I have to move the decimal 2 places in the 5,000. So that actually becomes 50 times 3, which is $150. So that's how much interest was earned on this account in 1 year. All right, the last bit, which I feel like was a thorn in everybody's side last year in algebra when we were learning about percent solutions, but it's really just the percent equation, right? Percent equals the part divided by the whole. And we're given the 5% acid solution. We're told to find out how much is acid. So what we're actually wanting to solve is the part. So to do this, we have to multiply both sides times the whole, which means that the acid, which is the part, equals the whole solution, excuse me, times the percent that's acid. So that means it's 2 liters times 0.5%, or excuse me, 5%, which is 0.05. Just making up numbers. Okay. Excuse me. So in this case, I'm just going to do 0.05 times 2. I know that that's 10, and I have two numbers behind that decimal place. So I'm going to move that decimal so that it is 0.1. And that's our answer. So the acid, the actual volume of acid in this solution is 1/10 of a liter. Okay, and that's it for the bell ringer. Let me share the screen. So what I've done also, which you should have either in your email or you got it before you left, was the notes worksheet that I made. So this takes all of the examples from section 3.3, and I've went ahead and put them there so you can work through them and kind of have them together on your own to see how we use what we've learned about systems of equations and apply that into real world problems. Obviously, some of these don't feel like real world problems, but they kind of are. These numbers that we're figuring out could apply to anything. So right now we just kind of use the sum of random numbers to teach our brains how to see the relationship between different numbers and how to find them out based on those relationships. So this first one hopefully is pretty simple. We know that we need to find two numbers and that their sum is 23. So we have our two numbers. You could say that x equals the first number, y equals the second number. And so we've got our x and y, and we know that x plus y is 23. And we're also told that these two numbers have a difference of negative 81. So unless they say, for example, if they said who's, so if they said, and the difference of between the second number and the first number, then you might do the second, you would use the second number first. But in this case, we're just going to make the educated assumption that they want the difference between the first number, which we have labeled as x, minus the second, and that equals negative 81. Excuse me. Okay. So now we have a system of equations. We have two equations. Nicely enough, either one of them is perfectly good to make or to use as a substitution. We're going to use the process of substitution here. Or the substitution, it should be substitution method to solve the system of equations. So I'm actually going to use the x minus y equals negative 81 because when I solve for x, that makes my y positive. So there's one less negative I have to worry about when I plug it into the other equation. So step one, we're going to set up one of these two equations to solve for x. So I'm going to add y to both sides. And when I do that, I get the x equals y minus 81. So now I have a y value that I can plug in for x to solve for y. And then we can use that to then solve for x. So I'm going to do that in the other equation, because remember, whichever one you use to create a solution for one of your variables to cancel it out, you must then use the other equation in the system to solve for the variable that you're trying to find. So if x equals y minus 81, then I'm going to plug that into my other equation. And for x, I'm going to put y minus 81 and then plus y equals 23. All right, so we don't really need these parentheses because this is all plus and minus. We're not having to distribute anything. So I'm going to leave it this way. This is y plus 80, or excuse me, y minus 81 plus y equals 23. So I'm going to do two things at once here. I know that I can combine y plus y to combine like terms, but I'm also going to go ahead and move this 81 over to the 23. So y plus y is 2y. And 23 plus 81 is 104. So the last step that we have, I have to solve for y, is to divide both sides by 2, and we get y equals 52. So once I have y equals 52, I can then use either equation to solve for x. Now, either one you can do is fine. I'm going to use the x minus y. Hold on, let me just get a different color here. Trying to make it obvious what my different steps are because I'm sort of running out of room. So for number 3, I've got y. So I'm going to pick one of the equations. I'll say x. I'll just use x plus y equals 23. And then I'm going to plug in that y as 52 equals 23. And then I subtract 52 from both sides. And I get x equals, so 23 minus 52, 52 is larger, so I know my answer is going to be negative. And, whoops, I closed it, hold on. And these are unlike signs, so I'm subtracting. So 52 minus 23, 12 take away 3 is 9, 4 take away 2 is 2, so x equals negative 29. So x equals negative 29, y equals 52. And there's my final answer. So I'm going to plug it in one of these two equations just to make sure that it works. So if x is negative 29 and y is a positive, so that's plus 52 and that equals 23. I'm going to use that first equation. I'm going to flip these. 52 minus 29. 12 take away 9 is 3, 4 take away 2 is 2, and that does indeed equal 23. So we check it, it fits, we're good. So that's the first example. That's the basis of how we take the written math and turn it into the system of equations that we need to solve for our variables that we're being asked to find. All right, so the rest of these look very similar to our previous problems when we were first learning about solving equations. But in this case, again, we have two different variables. So this is just sort of the next level of what we've learned in algebra. All right, so our example 2 says, Mr. Perry has invested a total of $10,000 in 2 stocks. AmeriCorp returned 8%, while Bancorp returned 10%. How much did he invest in each stock if his total return last year was $850? So we know that we're going to be using our base interest equation. So interest equals principal times rate times time. There's a couple of totals here that we need to know. So we know that his principal, his total principal is $10,000. And we know that the interest total earned last year on that 10,000 was 850. I'm just going to set that aside for now. For now, let's solve our x and y. X and y need to match what you're trying to find. We were asked to find how much he invested, which is the principal amount he invested in each account. Then that is the rate of interest earned is applied to that principal, and they get over a period of time, and you get interest earned on it. So I'm just going to make x equal the first account. So x is the principal invested in AmeriCorp. And y is the principal invested I feel like I'm spelling principal wrong. Oh well. Because there's like principal of the high school, and then there's principal like an idea. Maybe this is the same. Oh well. Anyway, let it go. All right. So our principal for AmeriCorp and Bancorp core, we don't know. So the principal is x and y. Now the rate is specific to each. We know that the rate he earned off of AmeriCorp was 8%. And we know that the rate he earned over on Bancorp is 10%, which is great. I'd love to have these. We know that the time was last year, so we're going to say that it was yearly. So it's just 1. So we're not even going to use that in our final equation because anything times 1 is itself. Don't bother. The gain on this is the principal times the rate. for the amount of time, which is 1. So I'm going to convert the rate of 8% into a decimal. So this is 0.08 times x. Y is 0.1 y. And that's the gain. All right, so now we need to figure out our two equations. The first one is usually you can find a simple one, right? We're asked to find principal, and we do know that the total principal he invested was 10,000. So we know that the principal, let's see, I'm actually going to change colors. So first step, the principal that he invested in AmeriCorp plus the principal that he invested in Bancorp equals $10,000. So we know that we have an equation there of x plus y equals 10,000. That's the first equation in our system of equations. I'm just going to highlight it so I can find it. All right, let's look at the next one. The second one is the total, because we're told, hold on now. We need to figure out what the principal is based on the gains that were made. So the second equation, and I can't get I think my internet's, there we go. I just need to get that to move up just a little bit. So this is our interest. So we know that the interest, we can calculate principal in terms of the interest rate, which is the principal times rate times time. But we know that the interest in AmeriCorp that he earned from the AmeriCorp account plus the interest that he earned from the Bancorp account was equal to 850. Well, that's our gain. So the interest in AmeriCorp is 0.08 x plus 0.1 y equals 850. Now, I'm in class, I did not get rid of the decimals. I'm going to get rid of the decimals. They just drive me insane. So we are going to multiply this entire thing by 100. So 100. So again, because we got to get rid of all the decimals, and that's in the hundredths place. So that makes this 8x plus y, no, 10y, right? Because that moves twice. So we got to annex in a 0 equals 8, 5, and then I'm adding 2 more zeros. So 85,000. All right. So there's my second equation in this system. Okay, so obviously one of my two is going to be again, we're going to use substitution again. One of these is very easy to create an equation of substitution. I am going to take let's see, this is step 2. So let's take our x plus y equals 10,000. And I'm going to solve it for x. I'm just going to subtract y from both sides. And don't come at me, I know I'm breaking my own rule, but I'm just going to leave the 10,000 in front. 10,000 minus y, that's x. So now I have a value for x. I can plug that in and calculate my y. And then I'll take that and calculate my x from it. So just keep the same color. So this is step 3. So I'm going to take, again, I use the x plus y equals 10,000 to solve for x. So I have to use the other equation in the system to plug in that value of x to solve for y. Can't use the x plus y equals 10k. So I have, let me get myself some more room. And maybe word is the worst. Okay, so this was 8 times x, which was 10,000 minus y, plus, was it 10y? Okay. My shoot. It says my screen share is paused. Resume. There we go. Plus 10y equals, this is not going to fit. Try to write smaller. 8 times 10,000 minus y plus 10y equals, what was it? Shoot, 85,000. There we go. Okay, now we can distribute. So when I distribute the 8 into both of these, I get 80,000 minus 8y plus 10y equals 85,000. Again, I'm going to do 2 parts at once. So I'm going to go ahead and combine my negative 8y plus my 10y, which gives me a 2y. 2, while also moving this 80,000 over, minus 80,000. All right, and when I do that, I combine these two. 10 minus 8 is 2y. 85,000 minus 80,000 is 5,000. And last step, we divide by 2. And we knew that half is 50. Half of 50 is 25. So half of 5,000 is 2,500. Tap on those 2 zeros. So that means that y equals 2,500. And my y is the principal invested in Bancorp. So that means that, I'm going to go ahead and put that here. So that means that 2,500 is invested in Bancorp, which hopefully you can, in your head, figure out that means that 7,500 was invested in AmeriCorps. What? And you're done. But let's do the math to prove that. So to prove it, we take our x, what was this? Step 4, I think. X plus y equals 10,000. So I'm solving for x now. I know that y was 2,500. And so, wait, no, that didn't work. Gotta get my signs right. Catch yourself when you make those errors. Because look, I'm telling you, you're not the only one that makes those errors, but you got to catch them. Okay, so we subtract the 2,500 from both sides, 10,000. Here's where we have to start borrowing. So that becomes a 10, that becomes a 9. 0, 0, 10 take away 5 is 5, 9 take away 2 is 7. And that proves that the amount invested in AmeriCorps is 77,500. All right, that is all that we did in class. We will finish these examples when we get to back to class on Tuesday. So just make sure you've got all of those. You've got your note sheet filled out so that you've got it to use during any assessments that come up. And otherwise, we are done. Y'all have a great weekend. Thank you so much.